Good morning, everybody. It is 7 o'clock in the morning, and I just realized that my daughter is sick, and I'm not going to be able to be here at school today. So I wanted you to still have this graphic organizer, so I'm making one for you on video. So we're going to use a sheet of paper, and what you're going to do is everybody needs to pause the video, get a sheet of paper. You can pick a color of your choice. I picked white so that everything will show up today. You're going to fold it in half, I think y'all call that hamburger style, like this, and then you're going to make 3 sections. So we're going to start by getting a pair of scissors and cutting it into 3 sections. So 1, 2, 3. They don't have to be perfectly even. I know some of you will want it perfectly even. I would fold it first if you want them perfect. So now that I have my 3 sections, what we're going to do is we're going to create 3 triangles. This triangle here is going to have even or congruent legs. It's going to be a right triangle. It does not need to be perfect, but you do need to mark that the legs are congruent. And this is going to be our 45, 45, 90 triangle tab. So when we flip this one up, we're going to know what to do under here. Of course, I need to cut it all the way up. Okay? Our middle tab will be our 30, 60, 90. So this means that one side needs to be a lot longer than the other. So we have 30 up here because it's always the smaller angle, and then 60 right there. Alright, so there's our 30, 60, 90, and let's label that 30, 60, 90. Now the next one's for all other right triangles. So you can just draw a couple different ones if you want to. Maybe make them different shapes. Well, right triangles, but different in that some are long and skinny and some are not. And this is all other right triangles. Okay? You don't have to label this the exact, you can write it all out, decorate it, whatever you want to do. Alright, so when we all get caught up to here, unpause the video. Alright, now everybody has this on the front, so we're going to open this up. And our 45, 45, 90s are where we had whatever this side length was that wasn't the hypotenuse, the other side was the same thing, and the hypotenuse is x square roots of 2. So the ratio set up would be x to x to x square root 2. In an example, would be if this is 7 and this is x and y, we would set up x, x, x square roots 2. Our 7 and x and y would go under here. So everywhere up here that I saw an x, I'd plug in a 7. And you can pick 2 different letters if you feel like that's going to get confusing. There's an x here. So this one would also be 7. So this stays 7. This one would become 7. And this one becomes 7 square roots of 2. So x equals 7 and y equals 7 square roots of 2. So that's how you would do the 45, 45, 90s. The 30, 60, 90, open that up. And what we had with the 30, 60, 90, and I know some of you guys are perfectionists and are going to use a straight edge to make them perfect. We have 60 here, we have 30 there. Alright? So for this one, if this is my x, this one was 2x, and this one was x square roots of 3. So remember, it's easy as 1, 2, 3. So my ratio is going to be x to x square root 3, 2x. For across from my 30, across from my 60, across from my 90. Okay? So once we set that up, you can write an example. So in my example, if I had x, y, and 14, under my x, x square root 3, and 2x, I would put x, y, and 14. So if 2x equals 14, divide both sides. I'll zoom in. That looks like you can hardly see it. Divide both sides by 2. So x equals 7. So I'm going to plug the 7 back into these two. So x equals 7. and y equals 7 square roots of 3. All right, for all other right triangles, we use trigonometry. So we use trig for all of these. So what we're going to do is we're going to set it up. We're going to circle a particular angle. We're going to note that across from that angle is the opposite side. What's right next to that angle is the adjacent side. And this one's the hypotenuse. Noting if we switch angles, it's going to switch the adjacent and the hypotenuse. If you are looking for a side, you'd use sine is the opposite side over adjacent side. You would plug in your angle in whichever one of these two you had. Or if you didn't have opposite or adjacent, one of those two, you had, let's say, opposite. Oh, that's not adjacent. Y'all, let me write tangent right there. That's hypotenuse. I hope some of you caught it. I'm sure you did. All right, cosine is what goes right here. And that is if we have the opposite. Nope. The adjacent. It's way too early for math, guys. I hope y'all don't try to take notes in this early in the morning. Adjacent over hypotenuse. Okay, cosine is adjacent over hypotenuse. And tangent of my angle is, here's that opposite over adjacent. So if I have the opposite and I'm looking for the hypotenuse, I'd use sine. If I had the hypotenuse and looking for the opposite, I'd still use sine. If I had the adjacent and I'm looking for the hypotenuse, I'd use cosine. If I had the hypotenuse but looking for the adjacent, I'd still use cosine. Same kind of thing with tangent. Just as to let you know, if you're looking for an angle, and again, I hope you watched me write this and then wrote everything down, you can still use the sine inverse, like say opposite over hypotenuse, and that equals your angle. You can do the same thing with cosine inverse, but that's going to be adjacent over hypotenuse. That'll equal your angle. Or tangent inverse, but now you're using opposite over adjacent, and that equals your tangent. I know Miss Dickman and Miss Churchill take good care of you guys today. I hope this graphic organizer helps you with your workbook and any work that you have. Please make sure you complete your task today, and thank you for watching.